Okay, welcome everybody to the October 2019 SNOC webinar from Annette, the role of soils in meeting the challenges of climate change. It's a great pleasure to hold this webinar, but now last year, or the end of last year, there was a National Soils Conference held in Canberra, and the Harold Jensen lecture was delivered by Annette Cowie. And after listening to that, I was so inspired by Annette's talk that I asked her to come and give this webinar. My personal, something that's very dear to my heart is having scientists deliver their message to the public, because I believe that that scientists are always the best people to give us the best information on the facts. And I love it when there's somebody who can talk about those really important things, but can deliver their messages to the general public. So I congratulated Annette after her talk and asked her if she could present this webinar. So I'm really pleased that she's here. Annette's background is quite incredible, so I will read it out to you. Annette's got a background in soil science and plant nutrition with particular interest in sustainable resource management. She's the principal research scientist climate in New South Wales Department of Primary Industries, and she's also the adjunct professor in the School of Environmental and Rural Science at the University of New England. Annette was a lead author of the IPCC's recently completed special report on climate change and land, and is a lead author on the IPCC's 6th assessment report. She is co-leader of the International Energy Agency Bioenergy Research Network, Climate and Sustainability Effects of Bioenergy within the broader bioeconomy, and a member of the Science Policy Interface of the United Nations Convention to Combat Desertification. She's recently completed a 6-year term as the Land Degradation Advisor on the Scientific and Technical Advisory Panel of the Global Environment Facility. Annette's current research focuses on sustainability indicators and climate impact assessment in agriculture and forestry, including life cycle assessment of bioenergy and biochar systems. So it's a great pleasure that I can introduce Annette. And
okay, sounds like it should be right to go. So thank you very much, Luke, for that introduction, and thank you very much for inviting me to give this webinar today. As you heard from that rather mouthful of an introduction, I am involved in a range of different international activities that are focused on the land, and Luke thought it would be interesting for you to hear about them. So I'm really pleased to have an opportunity to talk about these international policy initiatives that are increasingly recognising the importance of soil in meeting the challenge of climate change. Now, I'm sure I don't have to tell you that climate change is real. It's happening now. It's happening all around us. And the evidence is mounting for exactly what the scientists said was going to happen as a result of climate change. The temperatures are going up, the sea levels going up, the ice sheets are melting. We have extreme weather events all around us. If you're from where I am in the northern part of the state, we have the most incredible drought and fires happening all around as well. Climate change is here and it's real. And it's not surprising that it's continuing to happen because despite our various efforts, the CO2 concentration in the atmosphere is continuing to increase. It's now over 400 ppm, which is pretty scary. The 4 last years were actually the warmest years that have ever been recorded, with 2016 actually being the warmest year on record, and they reckon 2019 is heading to be the 2nd warmest year, just beaten by 2016. So the international community, the United Nations Convention Framework Convention on Climate Change, has been encouraging developed countries to take action on climate change, but they've realised that this is not enough, and so they were very pleased in 2015 when they met in Paris that the international community agreed to get together with all countries on board under the Paris Agreement to tackle climate change together. Now, the most important thing about the Paris Agreement was, at that time, that all nations were on board. Unfortunately, there's one notable exception at the moment. But the important thing was that all nations agreed that they needed to tackle climate change together, and that they needed to attempt to limit temperature rise to well below 2 degrees, preferably less than 1.5 degrees. And so they agreed that to do this, they would need to balance emissions with removals, that is carbon dioxide removals from the atmosphere, so that they would have zero net emissions or negative emissions in the second half of this century. And the way they're going to do this is that countries have the flexibility to determine their own targets. This is from the perspective of common but differentiated responsibility, an expression which means that developed countries have more of a responsibility, having contributed more to the greenhouse gases in the atmosphere and having more capacity to address this. And so countries have determined their own targets, but there's a common framework for reporting. And every 5 years, there's a global stock take. And so the expectation is that there'll be pressure for countries to ramp up their ambition as they see how it is being achieved through the global stock take. And also there's mechanisms for developed countries to provide financial assistance to developing countries. Now, the IPCC released the report on reaching a 1.5 degree target about a year ago. And what they said was that human activities have already warmed the globe by about 1 degree on average. It's actually higher over the land because the oceans buffer that temperature change, so it's actually higher on land. And that it's definitely worth trying to limit to 1.5 degrees compared with 2 degrees because the impacts on human and natural systems will be much greater at 2 degrees. Now, it's not quite too late, but it would require drastic cuts to our current rate of emissions to be able to meet that target. And it's likely that there would be a substantial requirement for carbon dioxide removal technologies or negative emissions technologies. The particular negative emissions technologies that they focus on in the 1.5 report are bioenergy. That's bioenergy linked with carbon capture and storage. They call it BECCS. And there's a few reasons why they focus on BECCS. One would be that bioenergy is a technology that's available now. You can use residues, you can plant crops that take carbon out of the atmosphere, then you use them as some sort of energy product. There's a range of different energy products you can make from bioenergy, so heat, power, biofuels that can be used in regular vehicles, but also in heavy transport, marine and aviation. So it's quite a versatile option. And it can be integrated with the existing infrastructure for power, for example, and provide a dispatchable source that can support the expansion of wind and solar. And so this is the option that the modelers have chosen to include in their scenarios. They also have reforestation, a fairly obvious opportunity for taking carbon out of the atmosphere and storing it in trees as they grow. There are a couple of other negative emissions options that they do mention in the report. These are things like enhanced weathering, direct air capture and storage, and ocean fertilization, which are, I guess, unproven and much lesser developed technologies that are going to cost a lot of money to implement, even if and have perhaps negative consequences, like putting iron in the ocean could have all sorts of ecological impacts. So those are mentioned in the report, but there isn't a high profile for them. And ditto for soil carbon management, which you consider a more natural form of carbon capture and storage. The Special Report 1.5 models a range of different scenarios for how the world might develop in future. The P1 scenario on the left there is one where all countries get together, all citizens take action, people act immediately to reduce their emissions. And in that sort of situation, there's not much demand for the negative emissions options. Whereas over on the right-hand side, the P4 is the opposite scenario, where we continue with business as usual with very high rates of greenhouse gas emissions because we continue to use fossil fuels, continued increases in population and travel and greenhouse gas intensive lifestyles. And in this case, there's a major need for the negative emissions technologies, BECCS in particular, to meet that target. And so they calculated that the area of energy crops that would be required by 2050 in order to meet a 1.5 degree target was between 22 million hectares or over 700 million hectares with the P4 scenario. And that's about half the total global area of cropland at the moment. So as you can see, that would be quite a drastic land use change. And that's one of the things that was looked at in particular in the IPCC's more recent report released in August, the one called Climate Change and Land for short. Its full name is actually the Special Report on Climate Change, Desertification, Land Degradation, Sustainable Land Management, Food Security and Greenhouse Gas Fluxes in Terrestrial Ecosystems. That's why we call it Climate Change and Land. And this report highlighted the intertwined nature of the relationship between climate change and land degradation. It talks about the huge pressure that the human population puts on the land and how there's a lot of degraded land as a result, and that climate change is increasing this pressure. And as climate change ramps up, it's going to be harder and harder to maintain land productivity and avoid land degradation. On the other hand, the report also highlights that if we introduce more sustainable land management practices, this can at the same time sequester carbon, contributing to climate change mitigation, but also increase productivity of the land and the resilience of our agricultural systems. There are a very wide range of sustainable land management practices, and the report looked at quite a few of them. I won't go through them, but down the left-hand side there, you can see a list of the practices, the land-based options that they considered. And if you do look at them more closely, you'll see that they're not mutually exclusive. So for example, under improved cropland management, you could be doing activities like increasing soil carbon, reducing erosion, etc. But what they did was they looked at each of these practices and they looked at how they can contribute simultaneously to the challenges that we're facing. And they found that in many cases, practices that deliver climate change mitigation also deliver benefits for adaptation, managing desertification and land degradation, and contributing to overcoming food insecurity. So all the blue there shows strong positive benefits of those practices. The red squares suggest there may be some challenges in the options that compete with food production. Most of those options are about increasing the soil carbon. The calculated estimate of theoretical potential to increase soil carbon would give us about 2 to 5 gigatons of CO2 equivalent per year, which is quite substantial, about 10% of the expected emissions in 2030. And I'm sure you're all familiar with the sort of practices that can build soil carbon. So they're things that increase the organic matter level in the soil, and largely that's about maintaining plant cover so that you have a continuous amount of carbon going into the soil, and ensuring that you're not losing carbon through respiration, through erosion, ensuring that plants grow well by addressing any constraints that are limiting production, such as nutritional constraints or compaction, retaining the stubble, retaining as much organic matter on the site as possible, introducing biodiversity into your agricultural systems, and then applying things like organic amendments. One of the practices that is highlighted in the Climate Change and Land report is biochar. And if you're not familiar with biochar, biochar just means taking biomass, many different types of biomass are suitable for making biochar, and heating it in a low oxygen environment. And it's essentially like charcoal, and it has very stable carbon. It doesn't decompose when it's added to the soil. And you can make it in various different scales, as illustrated here, from a small cook stove through to a plant that would process tonnes per hour. You can even make it in a pit in the ground, as long as you construct it carefully to ensure that you don't have emissions of methane and particulates. And so it's been found that when you add biochar to the soil, it has many advantages, or can have many advantages, in terms of stabilising the carbon. So we call it a natural form of carbon capture and storage. As the plants grow, they'll take the carbon out of the atmosphere. If instead of them decomposing and going back to the atmosphere, you turn them into char and put that in the ground, then you're essentially sequestering the carbon in a stable form there. And research has shown that biochar can improve soil properties in various different ways. Please remember, though, that biochars made from different feedstocks and in different ways have different properties. So not all biochars will have all these benefits. Note also that New South Wales DPI has been a world leader in biochar research. So a lot of this information has actually come from researchers in DPI, showing that biochar can have a liming effect. It's usually an alkaline product. It can increase the water holding capacity and nutrient holding capacity. It can increase nutrient use efficiency because it reduces leaching and volatilization of nitrogen, for example. And these changes in soil properties can increase plant growth, and it can also immobilize contaminants, organic and heavy metals, and so it offers a range of benefits for climate change mitigation and also for sustainable land management. And there's been a very detailed assessment of the potential for biochar to contribute to climate change mitigation, estimating it could be as high as 6 gigatons from a technical potential perspective. And so the Climate Change in the Land report looks at biochar and also BECCS and afforestation. And it has listed these as options that do have potential risks, but also opportunities. And so in each of these cases, they say, well, if these practices were to compete with food production, then there could be a risk to food security. But on the other hand, they could each be integrated with existing agricultural and forestry systems and actually have synergistic effects, but they need to be done well. So care is required in applying these technologies. The report also looks at policy options for enhancing sustainable land management, and one of the initiatives that it highlights is this thing called land degradation neutrality. If you haven't heard of it, it might sound a bit odd, but this is an initiative from the United Nations Convention to Combat Desertification. Having noticed that people really weren't interested very much in the land, and they hadn't recognised the importance of maintaining land productivity, they came up with this, I guess, slogan of land degradation neutrality. But the whole idea is that it's encouraging countries to take responsibility for ensuring that there is no net loss of healthy and productive land. The UNCCD's Science Policy Interface developed a scientific conceptual framework for the slogan. So we worked out what it would actually mean in practice from a scientific perspective, and then how countries could actually implement it. So the whole idea is that LDN encourages countries to maintain and enhance the land-based natural capital, to ensure flows of ecosystem services, to conserve land resource base, for healthy ecosystems, for food security, and in general for human well-being. And the mechanism for achieving neutrality is that any new degradation needs to be balanced by reversing degradation on already degraded land of the same land type. And we've said that you need to apply the principle of prevention is better than cure. So there's a hierarchy of responses, with the most important being to avoid degradation, followed by actions that reduce degradation. And here we're talking about sustainable land management practices in agriculture and forestry systems. and then strategic efforts to reverse degradation on degraded land. And the options for reversing degradation include restoration, which is a term that we use for actions that are specifically focused on the ecological outcomes, or rehabilitation, which is a term applied when the actions are intended to increase the productivity of the land for provisioning services, that is, so that you can increase agricultural production. Now, the most important thing we've said in attempts to achieve land degradation neutrality are that you need to plan now. It will be too late in 2030 when you check to see if you've achieved it to do anything about it if you haven't. So the most important thing is to keep track of the cumulative impacts of your land use planning decisions, and then plan measures to counteract any losses that you anticipate. The whole idea is that countries should think about the whole landscape, and they should apply an approach of integrated landscape management. This is kind of cute, I guess, diagram, not very relevant to Australia, certainly doesn't look anything like Armidale does at the moment. But the general idea is that land should be used according to its potential, or capability is the word we'd use in New South Wales for the same concept. And therefore land should be used for cropping where it's most suitable for cropping, and conservation and trees and urban areas as is best suited. So it's very important to be able to assess land potential, and I thought you might be interested in this little tool called Land PKS that's been developed by the USDA. It's a mobile phone app to allow land users to determine their land potential. It's actually entirely visual, so you don't need to be able to speak English to use it, for example. It was developed so that it could be used across the whole globe. And it's now being linked up to another couple of tools, WOCAT, which is a database of sustainable land management practices, and the carbon benefits tool, which is a carbon sequestration predictor. So Land PKS may be of interest to you, available at that website. We've also developed a framework to guide people in choosing the most suitable sustainable land management practices for their context, based on land potential, as I mentioned already, but then going through the particular context in terms of socioeconomic factors, for example, to determine which sustainable land management practices are most likely to be adopted and therefore successful in your context. The next thing to do was to come up with indicators for LDN, and this chart with lots of words on it is our list showing all the ecosystem services that come from the land. And the important thing here is the code here for what indicators may be relevant for each of these services. And we identified that there are 3 indicators that are quite widely relevant as proxies for these ecosystem services. And so there are 3 global indicators to be used for monitoring LDN. These are land cover, mostly the transition between forestry and cropping and pasture and urban. Those are the land cover changes that are particularly relevant. Land productivity, or productive capacity of the land, and carbon stock, but we're thinking here particularly about soil carbon. And the way these indicators are applied is it's on an area basis, so a pixel, and if any of these 3 indicators shows a decline, then that's considered to be degradation. So we call that a one-out, all-out approach. And it's also very important to ensure that this is verified on the ground, and that it's complemented by locally relevant indicators if the 3 indicators don't capture the things that are most relevant for your situation. So for example, if you had soils that are contaminated with heavy metals as a result of mining, it might be important to include an additional indicator for that. It's also important to include indicators for the processes that you're applying, so that you can monitor the activities and ensure that they're being undertaken, because it obviously takes quite a while before you'll actually see a change in soil carbon. The UNCCD has worked with Conservation International to develop a tool that will allow countries to be able to report on those 3 global indicators, because it wasn't possible for UNCCD to propose indicators that countries didn't have the capacity to gather the data. So this trends.earth tool allows countries to access the data to estimate those land cover, productivity and soil carbon changes, which may also be of interest. It can be used on a project level as well as being applicable at the national level. So far, 122 countries have actually signed on to set LDN targets and are in the process of validating and implementing those targets through policies. You may note that it's mostly developing countries that have actually signed on for LDN at this stage. And that's probably mostly because there is a funding mechanism to support developing countries through the global mechanism of the UNCCD, and now a new LDN fund. And there's also support for countries under the Global Environment Facility to tackle LDN as part of integrated landscape management. LDN is actually also one of the Sustainable Development Goals, the 17 goals that are part of the 2030 Sustainability Agenda. It's part of Life on Land, number 15. It's target 15.3, which says by 2030, combat desertification, restore degraded land and soil, including land affected by desertification, drought and floods, and strive to achieve a land degradation neutral world. The general idea is that countries would take on LDN targets and need to achieve them within their national boundaries. There's no trading between countries allowed. And as I'm sure you're aware, building soil carbon will have benefits for many of the Sustainable Development Goals. And so efforts for land degradation neutrality that increase interest and adoption of sustainable land management practices will deliver all these benefits in terms of enhancing productivity, and so meeting objectives for reducing hunger and poverty and improving health, and have benefits for climate change mitigation, as we've discussed already, and also for clean energy, for example. Now, I thought you might also be interested in one of the other messages that came from the Climate Change and Land Report, and this was the one that was publicised most widely in the media, and that was that the report came out saying people need to change their diets. In particular, there was a focus on eating less red meat or becoming vegetarian. Certainly the report did talk about the future of food and what food systems of the future might look like, and the various options that are now emerging quite rapidly of plant-based or fake meat, etc. But it didn't actually say that people need to stop eating meat. What it did say was that people need to eat a balanced diet that's rich in plant-based foods, and that will be good for their health and also good for the planet. It does talk about red meat, and what it says there is that there's evidence that reducing or avoiding red meat could potentially offer mitigation of 3 to 8 gigatons of CO2 per year, which is obviously quite substantial. But that calculation is not just about the methane emissions from ruminant livestock. It also includes assumptions that if you if less of the population of the world eats meat, there'll be less cereals grown to feed to cattle, and therefore there'll be spare land, and that could be used for carbon sequestration. So there's a lot of assumptions behind that calculation. The report also notes that ruminants are actually pretty smart creatures in terms of having a digestive system that can turn cellulosic biomass that people can't eat into nutrient-dense food that's very high quality protein. Also that we can only grow crops on a small portion of the planet. Only 11% of land is arable, and the rest of it really can't be cultivated because it's too fragile, too dry, too steep, too rocky, etc. And ruminants can graze that land and turn it into food for people. In fact, most of the livestock across the world do not eat food that's suitable for human consumption. Another relevant point is that including animals in cropping systems can actually enhance the sustainability and reduce the need for herbicides and fertilizers, etc. And that including pastures in your cropping rotation is the only sure way of actually increasing soil carbon in croplands. So it can be very important from that perspective. Another interesting point is that pastoralists play an important role in managing the rangelands, managing, for example, feral animals and weeds and fire. So they have an important role in the ecology as well. So all these things are important to consider, and it's not so simple to suggest that we should stop eating red meat. What it says is that we should think about the farming systems. And it talks about future farming systems, and there are some terms that are increasingly being used: climate smart agriculture, sustainable intensification, regenerative farming, and now a very popular one is agroecology. To me, these are all terms for sustainable land management. Another point that's raised in the report is that food waste and food loss is a major contributor to greenhouse gas emissions. About 1/3 of food produced is actually not eaten by people for various reasons. In developing countries, there's a lot of wastage and spoilage in the supply chain. In developed countries, it's mostly about us buying more than we actually needed, not eating all our food in restaurants, and throwing out a lot of food at the retail end and consumer end. One thing that will help to address that is the increasing interest in the circular economy. And so this has become quite a popular topic as well internationally. And in relation to the food waste, it has the potential to address two issues. And one is that the waste of inputs when we waste food, so you're wasting land and you're wasting all the energy and resource inputs. And then when you have food waste going to landfill, you have methane being produced, which is another greenhouse gas problem, of course. And so if instead we apply the circular economy principles, which would take food waste that can't be avoided and use it for energy in a process like anaerobic digestion, then the energy would be recovered and used beneficially to displace fossil fuels, and the digestate produced is a useful fertilizer. So we can get those nutrients back onto the land. The same should apply to biosolids, but in New South Wales, we already do a really good job of capturing biosolids and putting that back onto the land. So the key messages for Australia, for Australian agriculture in particular from the Climate Change and Land Report, the obvious one that climate change is increasing the challenge for managing the land. It's obviously already a challenge for our variable climate, but it's only going to get worse. We know that sustainable land management is one way to address this, and it offers us a win-win or even win-win-win in that building soil carbon enhances the productivity and resilience of our agricultural systems and sequesters carbon at the same time, and so it offers climate change mitigation and adaptation at the same time as addressing land degradation. The options of bioenergy, reforestation and biochar are going to be really important because we're going to need to take carbon dioxide out of the atmosphere if we've got any chance of meeting a 2-degree or 1.5-degree target. But they do have some risks, and so they need to be done well. We need to have policies that ensure that feedstock is produced sustainably and that we don't have displacement of food production through efforts to sequester carbon. And what we need then is policy that simultaneously encourages sustainable land management, climate change mitigation and adaptation. There's a lot of skepticism about the extent to which we can actually achieve that theoretical potential in increasing soil carbon. This is a small figure that came from a paper released last year from some people who were obviously quite skeptical about the potential. And there are a range of barriers, economic and also political and social barriers to the uptake of the mechanisms that we know will actually increase soil carbon. But in Australia, we're actually making some progress there. Our emissions trading scheme, the Emissions Reduction Fund, is one of the only schemes around the world that does actually recognise soil carbon. It doesn't recognise biochar at the moment, but we can cross our fingers that eventually they'll see the light on that one. There are a range of different other project types, and in fact soil carbon is not one that has had a big uptake. So amongst the 900 odd projects that have actually been registered, there's only something like 30 that involve soil carbon management. And as far as I know, only one of those projects has actually created credits yet. So although we have the capacity to have an incentive for soil carbon management under the Emissions Reduction Fund, it's not exactly working yet. Industry is also interested in improving its credentials when it comes to climate change. In particular, the red meat industry has noticed that this is a challenge, and so the MLA has come out with a target of carbon neutral red meat by 2030 and suggested that this is possible, and now undertaking various research and development initiatives to head in that direction. Another opportunity for soil carbon management. And so I'd just like to conclude now. I know I've walked you through a very wide range of international policy initiatives and reports, assessments, and I guess maybe I've filled your head with lots of different acronyms, and I apologise for all that. But I hope you have realised that there is now quite a lot of momentum. There's a growing recognition of the importance of maintaining the soil resource base. And there's actually a convergence. The pressures converging is unfortunate, but it also means that there's a lot more attention on the need to address these pressures. And there's also a growing number of solutions, because we now have the Paris Agreement starting next year. We have the land degradation neutrality target, and we have the Sustainable Development Goals. And so I would encourage you to promote this as an opportunity for the recognition of the role of soil in addressing all these challenges. And to take this on, that image I showed of the pessimistic approach from those researchers, let's try and address that. Let's try and encourage people to see this as an opportunity. It's not too hard. And so if researchers and landholders work together, we can change the minds of the policymakers who are sceptical and come up with ways to encourage sustainable land management that will increase soil carbon and actually increase the resilience of our farming systems. Thank you.
Thanks, Annette. Fantastic. I don't know how you do it. Take such complex worldwide issues and be able to do it all in 15, 20 minutes. So I really appreciate the complexity of that. Anyway, just going to our first question now, Annette. It's from, oh, we've got a few coming in already. Good. So the first one was one of your very early slides. Carol Rose asked what you had on the table. There was a table in one of your first slides, and it said, what was the capital L/capital M on the table? Do you remember that?
So that's talking about the confidence that we have in those assessments. So dark blue means that there's a big potential, and L means there's low confidence in that potential. And then over on the side here, we have an indication of costs. Of course, there's a huge amount of information captured in trying to make this sort of three-dimensional illustration of all these concepts. And the report does include a whole annex of how they actually came to these assessments.
Great. I'll go to Mark Arundel. And Mark has asked, how much CO2 is produced in the charring to make biochar?
Good question. About half the carbon in the char, well, sorry, in the biomass ends up in the char, and the other half is released. If you are able to make the biochar in a larger engineered facility, you can capture that syngas and use it as an energy source. If you do it in a really small cook stove, then you can burn that gas again to boil the kettle or whatever. The in-between scale options, unfortunately, it's harder to make use of that that resource as it's released. So hope that answers your question.
Great. Now, Greg Brennan has typed in a question here. The time lag for regenerating soil organic carbon and current ERAC approved methods means that it is often not commercially viable to introduce the required management practices, particularly in rangelands. Is there enthusiasm to develop a nationally coordinated R&D program to develop an ERAC approved soil organic carbon sequestration method for rangelands, as well as the required development of cost-effective methods to accurately measure soil carbon so that it can be traded on carbon markets? And Greg has kindly said he's from Grazing Innovation in Geraldton, WA, and I'm happy to read more of that bits back to you, Annette, if you need to hear it again.
Oh, no, that's fine. Yes, the current method under the ERF for soil carbon, there's actually two methods. One is requires you to measure the soil carbon change. So there's a baseline measurement, and then you come back and measure at intervals and calculate credits based on the actual measured change in soil carbon. And yes, that is quite impractical to apply in the rangelands. There is actually another soil carbon method that's approved under the ERF, but it hasn't actually been applied. No projects have been created under what's known as the deemed method, which means that the quantum of carbon sequestration is actually determined in advance based on practices. So it's been modelled based on the model that's used for Australia's National Greenhouse Gas Inventory. And so if you can demonstrate that you've applied these particular practices, there's quite a rigorous way of determining what's required in your particular case and then proving that you've done it. Then you can just estimate your soil carbon sequestration based on this model. And the model's been applied, and so there's a table of values. And to me, this is the sort of approach that would be applicable for the rangelands. I think what we need is a combination of something like remote sensing to determine that the practices have been applied, and then a model, the one we use for our National Greenhouse Gas Inventory, to estimate the change in soil carbon associated with those practices. I think that's the only way that it can be practical in the rangelands. And this is actually consistent with other methods applied around the world and being promoted under initiatives such as the cut per mille, the 4 per mil initiative that came from the French at the time of the Paris COP. And they're promoting an approach that doesn't require detailed on-ground soil carbon measurements. It just requires some type of baseline, maybe on a regional basis, and then application of a model. And we are hopeful that something like this can be generated and accepted under the ERF. There have been some efforts along these lines. Kathy Waters and Sue Zorgal have been working towards a concept for a soil carbon method for the rangelands.
And now I've got Problem Mirror has asked, from the implicative point of view, what are the application rates of biochar you can suggest under which crop it will have the maximum potential to sequester more carbon cost effectively? Cost effectively means if one has to balance out the carbon trade-offs between biochar production and use benefits, then what would be the figure from the implicative point of view? What are the application? Hang on, you can suggest which, I think it might have been repeated. Yes, okay, so it's typed out twice, okay.
Yeah, unfortunately, we don't really know enough about the ideal rates of biochar in broadacre agriculture. What we do know is that biochar is beneficial at rates of something like 10 tonnes per hectare, and often half that. There have been trials internationally to demonstrate enhanced biochars. So biochar tends to be most effective if it's actually mixed with other organic amendments or mixed with other nutrients, either during the pyrolysis process or afterwards. So we think that an ideal biochar application would be some sort of mixture, and in fact that's what they're doing in China. What they're doing there is that they've banned field burning of residues, so they have a lot of cereal residues, and they take those from the field. They have large-scale pyrolysis, they make biochar, and then what they do is they mix it with chemical fertilizers. So what they're doing is replacing some of the chemical fertilizer and making a prill and just applying it in the same way as you would normally apply fertilizer with crop establishment. And so obviously that way they're only applying a small amount of biochar per hectare, but they're applying it regularly, and so they're able to sequester all that carbon. It will take a while before that amount of biochar delivers discernible benefits in terms of productivity per hectare, but you'll be building up the biochar over time and sequestering the carbon, there's no doubt about that.
Terrific. Patrick Francis is saying, Annette, will the LDN concept become part of whole farm management approaches in Australia and other developed nations?
Yes, I showed that map of who'd signed on to LDN, and it was largely developing countries. The only developed country in the list at the moment actually is Italy, and they were part of a pilot, so that's why they're there. LDN's intended to be applied at a national level, or perhaps at a catchment level, or at what would be a natural level for land use planning. In Australia, of course, we do have some very large properties, and it may be relevant on an individual property if it's quite a large scale. But largely the concept of LDN is about creating a mosaic of land uses so that you can offset losses through something like urban expansion by restoring land in some other part of the same sort of land unit. And so that wouldn't naturally sort of lend itself to an individual property boundary, but what we are suggesting is that a national LDN plan should identify actions that need to be taken by different people in different parts of the landscape. And so there could be LDN projects which contribute to achieving the national LDN plan. And that's the sort of thing that the Global Environment Facility is funding in developing countries. So it's people involved in those projects need to be well linked into the national plan development and implementation, and the same could apply to individual landholders. As to whether Australia is likely to take on an LDN target, well, this isn't quite clear yet. At the last UNCCD COP, which was in India last month, the Australian delegate expressed some interest, and we encouraged her to take that back to her department. Interestingly, there's been quite a number of Australians involved in developing the LDN concept and developing the methods to access the indicators. Neil Sims from CSIRO is leading a group on that. Shani Wheeler, formerly Australian, she's currently living in the Netherlands, is working on the LDN fund, advising them on how to assess soil carbon. And so several of us have expressed our interest to the federal government in following this, but so far there hasn't been a lot of action. But likewise, a lot of developed countries have said, oh, we already have our own processes for managing land, our own indicators that we use. They're a bit different from what you're proposing. I guess I find that a bit disappointing. It is one of the Sustainable Development Goals. All countries have, at least theoretically, agreed to follow the Sustainable Development Goals. So I'm hoping that the countries will become a bit more serious about this and look into how they can actually achieve these targets, and therefore become more interested in LDN. And I guess we can all talk it up, the benefits of LDN.
Great, thanks Patrick. Good on you. Carl Anderson has asked, if increasing soil carbon is achieved through increasing pastures on arable land, what further offset would be required on site each year for additional methane from ruminants grazing those pastures, not including any increasing efficiencies?
Thanks, Carl. I don't have a simple answer to that. Certainly, as you've identified, there are a number of different strategies being developed or known that can help to reduce methane emissions. Seaweed is sounding promising, at least in the lab, and there are trials underway at the moment to see how effective that will be in practice. In the lab, it's proven to be quite dramatic, increases of up to 90%, decreases of up to 90%. So, of course, we've got our fingers crossed that that will actually turn out to be a feasible way of effectively reducing methane emissions from ruminant livestock. As to what the net that you would need to counterbalance, I'm not sure what that's going to be, but that's one of the things that I'm looking into as part of the current emissions reduction pathways project, and I have a current consultancy out to give us some ideas of the scale of the potential for each of these different strategies for reducing methane, and then we'll know how much is left over that we're going to need to offset with tree planting. They call it insetting, so offsetting that you do in your own supply chain. So planting trees around the edges of your paddocks, measures to increase soil carbon. Biochar. Oh, back on the biochar, there's an interesting demonstration in WA, a landholder who feeds his cattle biochar in a lick, and he's also introduced dung beetles, and there's been a measured increase in soil carbon as a result of that. So we'd like to see that demonstrated in a replicated fashion and published, because that's quite interesting too. And also there's a few papers on feeding biochar to cattle, and that has suggested that biochar itself in the animal feed could reduce methane emissions from enteric methane.
Terrific. Probably more of a comment here from Stephen Hobbs. You might comment back. Stephen said, I'd like to grow and manufacture a renewable fuel for use on farm from a portion of farm crops, but it's currently an ineligible activity to the best of my knowledge.
Yeah, I think it is currently an ineligible activity. Like I said before, I'm not really up on exactly where this would fit. I know in the original plan it didn't fit because it would only work for entities that are covered, entities with high emissions that have an obligation to reduce their emissions. So they could use something like biofuels to reduce their own emissions to meet that obligation, but you can't generate a credit by undertaking a project on farm that somebody else could buy, as far as I know, for that type of project at this stage. But you'll all be aware that the Emissions Reduction Fund has received an injection of taxpayers' funding to hopefully meet our agreements under the Paris Agreement, and so they are going to be looking for opportunities to increase activities. And so as each auction's gone by, there's been fewer and fewer projects offered. So I guess you could say that the low-hanging fruit has been taken up, and so now I guess there will need to be further effort in either expanding the range of activities that count under the Emissions Reduction Fund, or in changing the way the existing methodologies are applied to make it easier for people to become involved, to reduce some of those transaction costs, for example. So I guess I'm hopeful that there will be an appetite for different methods in the near future.
Carl Anderson's got another question. Hi Annette, is there a risk of re-emissions from oceans as atmospheric CO2 stabilises?
Now that's a really good question, Carl, that people tend to overlook. It's a bit scientific, I suppose, but the the whole idea is that when CO2 is emitted to the atmosphere, about half of it stays there and the other half is actually taken up by the oceans and by the biosphere through CO2 fertilization effect. And unfortunately, the reverse is also true. So if you plant a whole lot of trees and take a whole lot of carbon out of the atmosphere, what happens is the reverse process. So some CO2 is then released by the ocean and the biosphere as a result. And so this means you actually have to plant a whole lot more trees than you thought you were going to achieve a certain reduction in atmospheric concentration. This was pointed out after the paper was released. I'm not sure if you saw a paper, great fanfare. It was published in Science in about July by a chap called Bastin, and he determined that there were 900 million hectares of spare land in the world that could be reforested, and that this would amount to a sequestration potential of something like 200 gigatons. And people came in afterwards and said, yes, but you forgot the fact that there's a relaxation and you have to you will not achieve that. It may happen immediately, but then you will get CO2 being released back into the atmosphere, unfortunately.
Michael McDonald has asked, what's a practical way for a farmer to introduce biochar to the soil? What amendments to soil are most useful
to increase soil carbon? Okay. Okay, so in a grazing system, this idea of feeding it to the cattle is an interesting one and fairly straightforward. In a cropping system, it's a little bit difficult at the moment. There are people working on trying to develop the same product as I described is available in China. The fertilizer prill that has biochar in it, as well as chemical fertilizer, which will definitely be an easy way to do it. A landholder in WA tried injecting it in a band under his wheat crop. Part of the difficulty at the moment is that biochar is not supplied in a way that's easy to handle in a broad acre system. So people have tried spinning it out, but it tends to be fairly it's fairly fragile in terms of its physical structure. So, and some of the biochar that people have tried has been very finely divided, and so it tends to blow away. And it also can wash away because it floats. So some of our trials internationally, where we tried to use it in rice paddies, that was a bit of a problem. But basically, it means that you need to either inject it if you can put it in a drill, or you need to plough after broadcasting it to avoid those problems. And so that's why putting it in a fertilizer granule tends to be the way that will be most easily applied. If it's in a smaller, more intensive, like horticulture application, people dig holes and put a quantity of biochar under each tree in an orchard, for example. There have been trials doing that on the North Coast. Lucas van Sweeten's been involved in those trials. So that can be a way. I'm not quite sure what sort of agricultural system we're talking about here, but if you're thinking about broad acre cropping, that's a bit challenging at the moment.
Yep, thank you. So now Teresa Chapman from RMCG in Tasmania has asked, Annette, how do we find out more information about the soil carbon measurement method that you're talking about? Where do growers go for information? Good question.
Okay, so the Emissions Reduction Fund has a website. So if you just Google Emissions Reduction Fund, you'll find the website run by the Department of Environment and Energy that shows you a list of all the methodologies that are available. It's also listed under the Clean Energy Regulator. They also have a list. And if you go into each of the methodologies, then there's a whole lot of links that well, on the actual web page, there's some quite useful short information that talks about what it involves, what the eligibility rules are, and that type of thing. And there's also links that take you to the legislation itself, which can be a bit of a hard slog. and for some of them at least there's some fact sheets and some explanatory type of documents that are much easier to read than the legislation. So hopefully you can find that. It's I think fairly easy to find if you look up emissions reduction fund method. I realised I didn't actually fully answer a previous question about what were the easy ways of increasing soil carbon. I guess there's been a lot of research into the capacity for zero till to increase soil carbon, and essentially it doesn't do much in that regard. But if you did have a situation where you were burning stubble and cultivating, if you can change both of those practices to a minimum or zero till and retain the stubble, then that's been shown to at least avoid a loss of soil carbon. Because what tends to be the case is in most cropping systems in Australia, we're actually seeing a continual decline in soil carbon. And so if you can stop that decline, that's a good thing. That counts as a win. So you may not actually increase soil carbon by introducing stubble retention and zero till, but you'll stop it decreasing. As I said before, a pasture phase is the most certain way of increasing carbon in cropping systems, and increasing carbon in grazing systems is all about managing grazing to ensure that you do maintain ground cover and ensuring that you protect your pastures to allow seeding at the appropriate times of year, and ensuring that you destock early in a drought, etc.
Thanks, Annette. What do you see as the key opportunity in terms of management options for agriculture? That is, how can we get recognition of carbon management options in economics, not dollars, noting the 2018 PNAS paper you presented was pessimistic? Same as current question.
Yes. Well, I think this is along the lines of, well, we hope to understand better why some landholders are willing to implement more sustainable practices, things like regenerative agriculture, and why some others aren't, and why some people are signing up for the emissions reduction fund and others aren't. And this is the type of research we're doing under our current project, and hopefully we'll have a better answer once that project's finished in about 2 years' time. Part of the thing that has really annoyed me in being involved in these international processes is this overwhelming perception that landholders are the problem and that agriculture is the problem. There was a report released by the Intergovernmental Platform on Biodiversity and Ecosystem Services, which is the equivalent of the IPCC for the Convention on Biodiversity. And it was all about how agriculture has caused land degradation. And there was really no acknowledgement that, well, the agricultural systems that are used are kind of imposed by the demands of the consumer and by our current society, the way it works. So until we have a better recognition of the importance of paying for more sustainable practices, it's going to be really hard for those to be applied.
Yep. So Sue Briggs has asked, is the Australian Cool Farm Initiative another option to measure, manage and reduce greenhouse gas emissions? And do you know the uptake of this initiative?
There are a couple of different groups, I suppose, in Australia and also around the world who have developed their own ideas and their own tools for estimating greenhouse gases. And the Cool Farm tool is one of those, if that's what we're talking about. I'm not quite sure. And those are not actually linked to our emissions reduction fund. So it's going to be hard for those to be an incentive for landholders who are actually looking for an economic incentive. If people are just looking for some guidance on what they can do themselves that can help to address climate change, then tools like that are useful. There's also some simple tools that were previously developed by DPI, a carbon sequestration predictor, and there's tools that have been put together by the Primary Industries Climate Challenges Centre at the University of Melbourne that help people to estimate their greenhouse emissions. This is mostly focused on energy use and ruminant methane and nitrous oxide from fertiliser, and gives you some guidance on, so you can estimate your current emissions and gives you guidance on practices that you could change to reduce those emissions.
Peter Quinn has said, Annette, thank you for a fascinating presentation. Do you know, please, the approximate produced cost of biochar from a larger facility such as the one that Lucas was involved in planning?
So Peter's probably thinking about a couple of ideas that have come up. There was one with Ballina Council that was really close to putting in a plant, and their estimate was about $300 a tonne if they had been able to put in, I think it was a 4 tonne per hour plant. So that's the sort of figure people talk about. I understand that's similar to what they're doing in China. It's really no, well, we're in this chicken and egg situation. Until we have the plant, we don't really know how much it's going to cost. There is current plans for a bio hub in Cobar, utilising the invasive native scrub that's currently cleared and burned in the field completely to waste. And this facility is anticipating that it could produce biochar at an affordable rate, but I don't have an exact dollar figure for you, but it's all about the economics of the whole concept that uses highest value timber for high value uses and makes really high quality, reductant quality charcoal out of the highest quality timber, and then biochar's a co-product of the process. And so these type of integrated approaches to managing biomass and producing biochar are likely to be the most cost effective and able to produce biochar at affordable rates.
Great. And Stephen Hobbs has asked, have you looked at the use of diverse cover crops to draw down atmospheric carbon and store via tubers and roots in the soil?
Certainly cover crops and green manure crops are very important as a part of the soil carbon is basically built by carbon that leaks out of the roots of plants. So the more the less time you have in fallow, the more carbon you have going into the soil. So things like cover crops are really important in order to maintain that carbon input to the soil, and of course to protect the surface to avoid erosion as well. So that's one of the practices that's listed as contributing to maintaining soil carbon and hopefully building soil carbon. And I guess it's one of the things that people are focusing on when they talk about agroecology type approaches to farming systems, increasing the diversity of the farm system, because we do know that different plants have different roles in terms of the decomposition rate of the organic matter, in terms of accessing nutrients and water, and therefore maintaining the productivity of the system. Agroforestry is something that's promoted internationally. It's not big in Australia, but that could be something that we could look into further, increasing that diversity in order to increase soil carbon.
Now, Kathy Dawson's asked, what are the barriers to developing a whole of farm methodology?
Well, Kathy, I'm really not quite sure, because once upon a time I was actually involved in the earlier version of the ERAC, which was called the DOIC, the Domestic Offsets Integrity Committee. And in those days, they were talking about developing a whole farm method, and I don't really know why they've lost interest in it. I'm very much hoping that we can enthuse them for the concept again, because to me it would make sense as an encouragement to landholders to look at their whole system, and also hopefully to reduce the transaction costs of being involved in a range of different methods if you were trying to apply a range of different strategies, which obviously would be relevant in most properties to be doing things that reduce nitrous oxide, reduce methane, increase soil carbon, increase tree carbon, for example. And so being able to have a whole farm method that brings all those together seems to make sense to me, and it's something that we'll be continuing to push from DPI.
Okay, and Victoria Brunner's back on biochar. Have any tests been done to see if vertical tilling biochar into the soil, as opposed to what you're saying about just putting it on the top of the soil, unless I understood that incorrectly?
Yeah, there was one trial in WA where they put it in the drill. So where you would place fertilizer, they placed biochar. So that was a kind of finely divided powder sort of biochar that was able to be delivered that way. That's the only trial of that nature in Australia that I'm aware of. To me, that would make sense, that you'd be delivering it right into the root zone. And we know that plants really like to have biochar in the root zone. So where in horticultural applications, veggie gardens and that type of thing, where people have placed biochar kind of, with a shovel, you can see that the roots sort of preferentially go to the biochar. And we've seen that also in pot trials that we've conducted at the university to look at the impact of biochar on root proliferation. And so getting it into the root zone is a really important thing to do, also to avoid that that you lose it with runoff, for example.
Yep, lots of interest in biochar today. Stephen Hobbs has said perhaps a good way to apply biochar is to prill it and apply it with fertiliser, say at 10%, so it'd be applied every year.
Yep, that's exactly what they're doing in China, and that's what I think would be a really sensible way of doing it, because that way, there's no extra actions involved. So and so it's pretty easy to do it, and you're reducing the amount of fertilizer that you're applying, maybe just by a little bit, but any reduction is important. And the biochar itself in that prill is going to reduce the leaching and volatilization of the nutrients as they dissolve. So that's really important for increasing nutrient use efficiency and reducing nitrous oxide emissions.
Thank you. As Victoria said, is too much carbon in the soil a problem? Good one.
That'd be a good problem to have. I mean, completely organic soils such as peats and many of the soils they have in Europe can be a bit problematic. I've always been surprised driving around Europe to see how much deep cultivation people do, and it's because they have these really heavy soils with a lot of organic matter, and they have problems with disease because you have lots of fungus and that type of thing. So maybe too much organic matter in a cool, wet climate could be a problem. I don't think it's a problem we're likely to be facing in Australia. So organic matter is all good as far as I'm concerned.
Fair enough. Oh, look, thank you so much for your presentations. That's absolutely fantastic. You've covered off on so much stuff, but I think we'll call it a day until next month for our next webinar. But congratulations and thank you so much again, Annette, on behalf of everybody. And there's many people who've written in here saying thanks for a great talk. So
okay,
thanks for listening, everybody. Yeah.
Thanks very much for the opportunity.